Hello, this is Stephen, and I would like to give a tutorial on how Anton achieved this connection between a Lego robot and a gamepad, in this case a PS4. This tutorial will dive a little bit deeper into the program and into how we provide you with enough tools to get this going yourselves. What Anton shows here is that he uses our LMS-ES32 board with a special firmware on it that connects to the Bluetooth gamepad, and at the same time is connected to a Technic hub, in this case running PyBricks. So there are a few ingredients you need before you can do this. First of all, you need a PyBricks flashed hub, and you need a special firmware on your LMS-ES32. So let's look into first the PyBricks and then what kind of firmware you need on your LMS-ES32. PyBricks is an alternative for the Lego Python program environment, and it has done a great job in the sense that it runs on almost all Lego hubs that use the Lego Power functions. So such as the Technic hub, but also the Mindstorms and the Spike Prime hubs, and some other hubs as well. And it runs from the browser. So if you start coding, you come into this coding environment, and you don't need to install any IDE or any program on your local PC. Here are the hubs that are supported. A whole lot of different sensors are supported, and to install it, the only thing you need to do is use this settings. You choose to install PyBricks. You have to choose the hub on which you want to install. You get a step-by-step guide that takes you all through the installation. The installation itself is quite harmless in the sense that you always can restore to the official Lego firmware again. So there's no risk of bricking your hub or something. It really works flawlessly. Once you have installed the PyBricks, then you need on your ESP32, so that's the board that connects to the PyBricks, you need to install a firmware. And we have a firmware installation website where you can choose different firmwares, and you choose here the BluePad 32 Lego Power function for PyBricks projects. That flashes the correct firmware onto the ESP32. This firmware is based on a project developed by Ricardo Quasada, and he did a marvelous job in that he allows now for almost any Bluetooth Classic gamepad to connect to an ESP32. He made several environments, and we are quite happy that he also now provides an Arduino library to integrate this so-called BluePad 32 functions into Arduino. And that allows us to make a dedicated firmware where we integrate this BluePad 32 together with the communication of the ESP32 to the Lego hub. So let's look at what I have here on my table. So I zoom a little bit into detail. So what I have here is my Spike Prime hub. To that are connected on port A the LMS ESP32, and the ESP32 has two devices attached to it. One is a circular 24 pixel NeoPixel ring, and the other one is a servo motor connected to one of the servo ports. And I have here a Nintendo remote or Nintendo gamepad connected with Bluetooth Classic to the ESP32. These NeoPixels are serial pixels using only one data line, and they can pass the output to the input of the next pixel. And that way you can make a string of pixels only needing one single data wire, a ground and a plus 5 volt power supply, and that's all you need for a number of pixels to use. So what I would like to do is go into the program environment and look how that works. So we go into coding, and I already are connected to the hub. So if you do this, no, it's disconnected. Now I can choose. No, this is not working correctly, I think. Okay. Okay, now I can connect to the hub. It was still running a program, so that was the reason it behaved a little bit strange. So let me clear this. So what I can do now is entering using this this on a REPL in the PyBricks command line. And now we can like manually look how this BluePad 32 is used. So we made a library. It's called BluePad, and that supports the different things that we need. So first we have to load the library. We instantiate a BluePad on port A. That's the port to which we connect. And then we have a number of methods available. One of the methods, the gamepad. And if I do this, it starts reading the connected gamepad. So in this case, you get 6 values. The first 2 is the left joystick XY. The following 2 is the right joystick XY. Then we have the last byte here. The second last byte is the buttons, which are encoded in bits. So every button has its own bit representation. And this is the D-pad. This is a small cross button, which is on this side of the gamepad. Let's put this in a loop so you can see how this looks. So I just start reading it in a loop. Now you see that it's erecting quite fast. So if I now change the joysticks, you see that these values are changing. So the left joystick, the X goes from -512 to +512. The Y vertically from -512 to +512, and the same goes for the right joystick. This also has these boundaries. And then the buttons, for instance, this one is the first bit, this is the second bit, the third bit, fourth bit, and these have even higher bit values, the buttons on the back. You can also press a few buttons simultaneously, you get the bit representation of these combined bits. And the same goes for the D-pad, which has only 4 states in this case, and it's the final byte. So by using these 6 values, you can read all the information from your gamepad and use that in your program. So that's the first thing. Then there are 2 other things supported in I should keep in this. So I reload the BluePad library. Now we can look into the NeoPixels. The NeoPixels have to be initiated first before we just start using it. So you have to set the number of pixels, in this case 24, and the pin, the GPIO pin to which the pixels are connected. In my case that's GPIO 12. Now it's initialized. And now I can use things like NeoPixel, for instance, fill. Now I can fill the whole ring with a specific color. Colors are always tuples of RGB values, byte values, so I can red, green, blue. So now I get the red one. If I want to change that, for instance, to green, I put that value there, so it's green. And I can switch the LEDs off by doing 0. And switch all the LEDs off. And I can also set individual pixels. I need the pixel number. So let's say 0. And then the color. Put a red pixel. I can put next to that, I can put on one, I can put a green pixel. And next to that, and on the opposite side, so that's the last pixel in the whole chain. Put that blue, so now you can see that you can address every individual pixel quite easily, and you can decide whether you do a write to the NeoPixel every time, or that you collect the number of pixels and do a write after that. That's that. Another option that we have is the servo motor. So we can set servo. There are 4 servo positions that we allow. So 0 to 3. So this one is connected to port 0. Not the GPIO, but servo 0. And I can specify an angle between 0 and 180. So if I set 0, I will reset it to its initial position. I can set 45, for instance 90, maybe 179. That's the largest position. If I go to 180, it wraps around and it goes back to 0. So that's the way you can change servos. Keep in mind that servos are not, I mean, if you go from one position to the complete opposite direction, for instance, if I do this, the servo needs some time to go there. So that's up to you how you deal with that time, of course. So these are the basic functions. So let's look at a few examples that I've made. We also provide these examples on the GitHub. So let's say a more generic example. What this does, let's run it and then I show you what it does. It flashes the pixels, and then now it's waiting for the reading of these gamepad joysticks, and with each joystick a position on the ring is controlled. So you can just use the angle of the joystick is determined, and the corresponding LED is lit, and then the same goes for the right joystick with a green LED. And you see, if you use both of them at the same time, you see it's quite responsive. It goes very fast. I measured it. It's like less than 10 milliseconds per LED setting. So that's quite fast. It also that's this example. So you can have a look into this code. It's quite self-explanatory, and I use these basic functions I already showed. So the NeoPixel init, the fill, the 0. I set a set for every bit, and I read here the joysticks and the buttons from this gamepad. So let's look at another example. This is an example just specific for the Prime Hub, because we will be using the display of the hub. So let's run it. At first it drives the LEDs in a pattern. So that happens here in a loop of 1000. You see that it's driving LEDs with different values. It drives the servo. What you also see is that while driving the servo, it can still read the gamepad values, and then it waits now for these two joysticks, and it displays one single pixel on the hub, and I can control this pixel using the joysticks. And the second pixel is the other joystick, and you see also here that it's really quite responsive. So this allows you to control all kinds of robots, cars or whatever, using this gamepad in a very fast way. Before you can use this, you have to load some libraries into the PyBricks environment. And the first library you have to do is the BluePad library. And where are these libraries? Where can you find them? You can find them in the pub remote repository. In the source, you see a number of libraries. The BluePad library, of course, you need. The BluePad library depends on the pub remote library. You see 2 versions. The pub remote is the generic version that also runs on the ESP32. We don't use that now, so we've made a stripped down version where we removed all the ESP32 dependencies and just one that runs on the hub alone, and that's called pub remote hub. So ideally you should take this one and the BluePad and load that into the PyBricks environment, and you should rename this one to pub remote, or just take this one. So if you see how do you load libraries, you can upload or import a file. So you clone the repository and you import a file from the local files, and they end up here in this list. And PyBricks is smart enough that if you use, for instance, this import function, that it knows where to find the library locally in the hub, in the environment. And it loads the library itself. And this BluePad uses the pub remote library, and that is also loaded from this environment. And then you can start coding. And what you will see is that this PyBricks environment is a very easy way of programming it. It's very fast. You can immediately run your program, and yeah, I really like it. And also the REPL prompt is easy to debug things and to try small parts of your program before you make the whole program. So that's the way I always use this. Let me see. So this is this. Yes, and then I already showed you where to load the firmware. This firmware has not only the function to read out the gamepad, but also to drive the NeoPixels and the servo motors. So that's a good thing to keep in mind. I think that's it. If you want to know a little bit more about the pub remote library that is used underneath this BluePad library, you can read this post on Anton's website, and you will find some pointers to the pub remote, and then you can program the LMS-ES32 yourselves to your own needs. But I think in providing a firmware with a default kind of functionality helps quite a lot in people that are not ready or not want to start programming on the LMS-ES32. Keep in mind, if you flash this library of this firmware and you want to start using MicroPython again, you have to reflash the ESP32 with this MicroPython library. I've also added the version 1.20, which is already available for people who like to use that, can also use that one. So I hope you find this useful, this tutorial. This goes with the post on the website, so there you find all the pointers to the various repositories that I mentioned in this tutorial. Good luck and see you next time.